Good morning. Am I audible? Am I audible, sir? Hello. Am I? Okay, 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 sir. Okay.
It is truly a privilege to introduce a distinguished academician and researcher, Dr. Amit Kumar Singh, sir. Sir, currently serving as an assistant professor at the Center for Data Science in the Department of Computer Science and Engineering at Siksha Anusandhan University, Bubaneswar, has an impressive academic journey and a thriving career in both teaching and research. Sir embarked on his academic journey at the prestigious Indian Institute of Technology, Kharagpur, where Sir earned his Doctor of Philosophy in the Department of Mathematics. Sir groundbreaking research focused on the construction of broadcast encryption and multi-signature scheme. Under the guidance of Professor Saurav Mukhopadhyay, this research has contributed significantly to the field of cryptography. Prior to PhD, Sir pursued a Master of Technology in Computer Science and Data Processing at IIT Kharagpur. Sir educational journey also includes a Master of Science in Mathematics from the University of Allahabad and a Bachelor of Science in Information Technology and Mathematics from Chhatrapati Shashuji Maharaj University. As an assistant professor at SOA University, Saw has been actively involved in shaping the minds of aspiring students. Saw diverse range of courses from programming in Python to linear algebra and complex analysis, etc. Some of the notable contributions include efficient multi-signature scheme using lattice and cloud-assisted semi-static secure accountable authority identity based broadcast encryption featuring public traceability without random oracles. Furthermore, Sir has actively contributed to conferences, workshops, and seminars both as a volunteer and as a speaker, and also include lectures on advanced topics in cryptography and participation in workshops. Sir's technical skills encompass software proficiency in MATLAB and LaTeX, programming languages such as C and Python, and experience with operating systems like Linux and Windows. Sir is a University of Allahabad rank holder in MSc. Thank you.
Yeah, thank you, sir. Thank you so much for the nice introduction. So I am thankful to MD Sri Reddy, Director Srimati VK Sriwani, Principal Dr. Surya, Head of Department and Convener Dr. P. Namrata, Coordinators and Organizing Committee for organizing this faculty development program and inviting me for a talk. So basically today we will discuss about blockchain and cloud. So nowadays every researcher is using blockchain technology in their field. In fact, nowadays many technical institutes like IIT, triple IT are distributing their degree certificate through the help of blockchain technology. Medical people are storing sensitive medical data on the blockchain. Also nowadays almost everyone is using the cloud technology in their mobile phone. Everyone is using Dropbox or many cloud storage devices. So today we will discuss which cryptographic technique is used to provide security in blockchain as well as cloud. So first of all, we will discuss the first application of blockchain technology. First of all, we will discuss how blockchain technology works and what was the first application of blockchain technology. So let me share my screen. So is my screen is visible? Yeah, thank you. So we will discuss about blockchain. So basically blockchain was the foundation behind Bitcoin. Actually the first application of blockchain was Bitcoin. So one by one we will discuss about Bitcoin and security, what cryptographic technique is used in blockchain technology. So this is the introduction regarding Bitcoin. So basically Bitcoin is a popular cryptocurrency, it means a digital asset, and Bitcoin network record all Bitcoin transactions in the blockchain, that is called blockchain ledger. So anyone can join the Bitcoin network by running open source software freely available on the internet. So now we will discuss what are the cryptographic technique used in blockchain technology. So basically cryptography is the backbone of blockchain technology, which provides security in stored data. So first cryptographic technique that is used in blockchain is cryptographic hash function. So cryptographic hash function has many applications. So first we will see its application in blockchain technology. So a cryptographic hash function is a mathematical algorithm that can take an input or any message and produces a fixed size string of characters, which is typically a hexadecimal number that can be converted into binary. The output, often called the hash or the hash value, and it is unique to a specific input. For a unique input, output will be unique. So here H is a hash function which can take any arbitrary message and will give a fixed size output, that is called hash value. Now one by one we will discuss some properties of cryptographic hash function. So first property is hash function is deterministic. Deterministic means for the same input, the hash function will always produce the same output. So if the x is same, then the output value y will be same. Second property is that it produce fixed output size. It means the hash function generate a fixed length output regarding the size of input data. Also, it is easy and efficient to compute. It should be computationally efficient to compute the hash value for any given input. Next property is pre-image resistance. Pre-image resistance means it should be very difficult to find the pre-image of a given value. For example, suppose you have this value y, then it is difficult to find this value. So this is called pre-image resistance. Second property is collision resistance. It means it is difficult to find, suppose you have the value y which is equal to h of x1, then it is difficult to find another x2 such that h of x2 is equal to y. So this property is called second pre-image resistance. Now this is the collision resistance. So in this property, it is difficult to find any two masses x1 and x2 such that h of x1 is equal to h of x2. Of course, it is possible, but not easy. Why it is possible? Because you can see here, the codomain contains 2 power n elements. So definitely after 2 power n elements, there will be a collision. In domain, you will find 2 elements that will map on the same value because the codomain size is fixed. Also, one of the very important property is avalanche effect. So avalanche effect means if you will suppose here y1 is the image of x1. So basically here suppose y1 is h of x1. So in avalanche effect, if you will change any bit in this message x1, for example, suppose I am changing this bit 1 to 0 and creating another message x2. So in this way, the image of h of x2, I mean there will be many bits change, many bits will be changed in the output message in y2. So you can see here many bits has been changed. In place of 0, 1 is present. In place of 1, 0 is present. So this is called avalanche effect. A small change in the input should produce a significantly different hash value. Also, one property is non-repudiation, means once a hash is created, it should be infeasible to modify the input without changing the hash. Cryptographic hash functions are widely used in security applications, including digital signature, password storage, and data integrity verification. So, in blockchain technology, SHA-256 is used as a hash function. So basically, SHA-256 stands for Secure Hash Algorithm 256 bit. So it was designed by National Security Agency and published by the National Institute of Standard and Technology in 2001. SHA-256 is widely used for various security applications and is considered to provide a high level of security. So this hash function is used in blockchain technology. So this hash function provides all features of a cryptographic hash function. So definitely SHA-256 arbitrary length input and gives a fixed length output, basically 256 bit. So there are many applications of hash function. So one of the important application is hash function is used to provide tamper detection. Suppose, for example, here suppose this is Alice and Bob. Suppose Alice wants to transfer a message X to Bob. Then what she will do? She will send the message X together with the hash value C, X and C. And after receiving X and C, Bob can verify that whether the message X has been modified or not. What Bob will do, Bob will run a verification algorithm and he will check whether h of x is equal to c or not. If h of x is equal to c, then there is no change in the message. Otherwise, Bob will verify that message has been changed. Now we will discuss the data structure behind blockchain technology. So basically in blockchain technology, there are different blocks and each block is connected with the help of hash function. So one by one, we will discuss how the blocks are connected in blockchain. So first we will discuss about hash pointer. First, we will discuss what is the data structure in blockchain technology. So basically a hash pointer is a concept used in computer science and data structure, particularly in the context of blockchain technology and linked data structure. It combines a pointer, a reference to a data with hash value. The primary purpose of a hash pointer is to provide a secure and efficient way to link and verify the integrity of data. Now we will discuss how hash pointer works. So basically this pointer component of a hash pointer is like a reference or a address to some data. It could be a memory address, a URL, or a path, or any means to locate the data. This may be any data. This can be Bitcoin transaction or any data. Then this hash value is the hash of the given data. So basically in blockchain technology, this hash is SHA-256. So basically hash pointer is tamper evident data pointer. So by combining the pointer and hash value, a hash pointer creates a connection between the reference to the data and secure checksum of data itself. And this has several advantages. We will discuss one by one. First one is integrity verification, then efficiency and immutability. So what we do in blockchain, suppose there are two blocks, block 1 and block 2. So in one block, there may be some data, and timestamp means when the data has been created, and hash pointer of this block. Then next block will contain another data, hash pointer of previous block, and then the timestamp. So here two blocks are connected with each other with the help of hash function. So this technique provides the integrity verification. Anyone with the hash pointer can compute the hash of pointed to data and verify that it is match the stored hash value. If they match, it indicates that the data has not been tampered with. For example, suppose this data is changed. Suppose there are many blocks connected with each other with the help of hash pointer. So this is block 1, block 2, block 3, block 4, block 5, and so on. And each block is connected with each other with the help of hash function SHA-256. And this tamper evident linked list is called blockchain. So here each block is connected with each other. And suppose someone is trying to change some data in block 2. So if someone will try to change this data, then the hash pointer of this block will be changed. Simultaneously, the hash pointer of next block will be changed. And very easily we can identify that there is a tampering in block 2. So with the help of hash function, we can identify tampering. Now, there is another data structure that is called Merkle tree that is used in blockchain technology. So, basically, Merkle tree is a tamper evident binary tree. So, basically, a Merkle tree, also known as a hash tree, is a binary tree structure used in computer science and cryptography for efficiently verifying the integrity of data in large data set. The Merkle tree employs hash pointer and hash function to create a hierarchy structure of data. So there are leaf nodes. Basically, this data structure is used to store transaction in Bitcoin network. That's why I am explaining about Merkle tree. So basically, there are leaf nodes. So these are the leaf node. So the lowest level of tree consists of leaf node, each representing a small chunk or block of data, and the data in each leaf node is hashed using a cryptographic hash function. Especially in blockchain technology, SHA-256 is used. Now this is the parent node. So moving up the tree, each parent node represents the hash value of concatenation of its own two sides. For example, this parent node will contain the hash pointer of this leaf node and hash pointer of this leaf node. And this one is the Merkle root. So basically the Merkle root is the topmost hash value in the tree. It uniquely represents the entire data set because any change in the data, no matter how small, would result in a completely different Merkle root. If there will be any change in any node, for example, suppose someone has changed this data, then the root of this hash root will be changed. So the Merkle root is often included in a digital signature or blockchain block header to provide a concise representation of the integrity of entire data set. So basically, this hash pointer is stored in blockchain. We will see how this is stored in blockchain technology. So basically, Merkle tree offers several advantages like efficient integrity verification, tamper detection. So for example, suppose someone has changed this data, then this hash pointer will be changed, then this hash pointer will be changed, and finally the root node will be changed. So it means there is tampering in the data set. Now Merkle tree are widely used in various applications including blockchain technology such as in Bitcoin's block structure, distributed file system, and data storage system, where data integrity verification is crucial. Now we will discuss another cryptographic primitive, that is digital signature, that is used in blockchain technology or Bitcoin network. So basically, a digital signature scheme is a cryptographic technique that enables the creation and verification of digital signature, which are electronic equivalent of handwritten signature or stamped seals. So digital signature provide a way to ensure the authenticity, integrity, and non-repudiation of digital message or document. And so basically there are three algorithms in digital signature. First one is signing algorithm. First one is key generation algorithm. Second one is signature algorithm. And last one and third one is verification algorithm. So suppose here Alice, there are two persons, Alice and Bob. Suppose Alice wants to sign a message M and she wants to send this signed message to Bob. So first she will run this key generation algorithm with security parameter, and this key generation algorithm will give secret key and public key. Now with the help of secret key, Alice will run this signature algorithm and sign, and this sign algorithm will take the secret key of Alice and the message M and create the digital signature S. And Alice will send this digital signature to Bob. Now Bob will use the public key of Alice PK, message M and signature S to verify that whether Alice has signed the document M or not. So Bob will run this verification algorithm. If verification is true, then he is convinced that Alice has signed the message M. So digital signature is used in the blockchain technology or Bitcoin network. So there are many applications of digital signature to sign. For example, if you want to sign a document digitally, then you can use the digital signature scheme. So a special type of digital signature is used in blockchain technology. So basically there are many digital signature scheme. Many digital signature scheme are based on pairing. Nowadays people are working on digital signature scheme which is secured against quantum computers, because after development of quantum computers, pairing based cryptography is on high risk. So nowadays people are working on digital signature, and there are many types of digital signature scheme. But in blockchain technology, a special type of digital signature scheme is used, that is called SECP256K1. So basically this curve is used in blockchain technology to create elliptic curve digital signature scheme. So here the elliptic curve is given by these points x, y, where x is the field from FP and y is a point from field FP, and the curve is given by y square is equal to x cube plus 7, where this prime number is given by this. And in this elliptic curve digital signature, the size of secret key is 256 bit, and with the help of this secret key, a public key is generated with the help of base point G. So here public key will be SK into Z, where base point is given by the point X and Y. So this is the point multiplication in elliptic curve digital signature scheme, and the size of public key is 512 bit, and the signature size is 512 bit size. So basically this is overall idea of SECP256K1 digital signature scheme. Now we will discuss about Bitcoin. So the actual application of blockchain technology. So as already I have discussed about the blockchain. So blockchain is a chain of many blocks. So actually the first block was created in 2009, that is called Genesis block. So here each block is connected with each other with the help of hash function. So basically only two cryptographic primitive is used in blockchain technology: hash function and digital signature. So here each block is connected with the help of hash function. So the first block was created in January 2009, and as of November 2023, the blockchain had more than 81 lakh blocks and occupied approximately 521 GB of disk space. And until August 2017, the maximum size of a block was 1 MB. But in August 2017, a new feature called segregated witness was activated in Bitcoin network, which effectively increased the maximum block size to 4 MB. So in blockchain, there is a block header, and every block in blockchain begins with 80 byte block header. So this 80 bytes block header contains some data. For example, the version of the block, hash of previous block, hash of Merkle root, n time, n bits, and a nonce value. So one by one, we will discuss about these terms. What is the version? What is hash of previous block? What is time? What is bit? What is nonce? So basically, finding this nonce is called Bitcoin mining. We will discuss later on. And these fields are taken from the source code of Bitcoin core client reference. You can find these details from the site blockchain. Here you can see. So this is the site of blockchain. So you can see here there are many applications of this blockchain. So one of the application is Bitcoin. So you can see here there are several. This is the blockchain. So this is the number of block, and this is the current market cap. This is the hash algorithm that is used in blockchain technology, SHA-256, and the first Genesis block was created on 3rd January 2009. So you can find all these details from here. This is the all transactions in a block, and basically this blockchain technology or Bitcoin network is completely based on a white paper that was published by an anonymous person that is called whose name was Satoshi Nakamoto. Till now, his identity is anonymous. No one knows who had created Bitcoin. So he published a white paper. You can see from here, this white paper is publicly available. And the whole concept of Bitcoin is based on this white paper. This is only, I think, 6 or 7 page white paper you can find from here. So in one block, for example, suppose I want to see this block. So once we will open this block, we can see all the data available in this block. So basically this block is containing all these transactions. Then this is the Merkle hash. This is the Merkle root. Then this is the number of transactions. This is the reward value. I will explain what is the reward value. Here miner is unknown. So this is the version. This is the size. This is bit. This is the nonce. I will explain what is nonce. So one by one we will discuss. So this basically the prefix n of 4-byte field is a convention that these represent integer value. So basically, this nonce is an integer value, bits is an integer value, version is an integer value. So one by one we will discuss about these terms. So n version specifies the version of the block. After some time there is an update in blockchain or Bitcoin network. So this indicates the version. Then hash of previous block. So basically each block is connected with the help of SHA-256, but in blockchain network actually double SHA is used to chain two blocks. Here you can see, suppose this is the previous block, then we will compute the double SHA-256 and compute the hash value in the next block. Now why we are using, or why blockchain network is using double SHA-256? So basically there is an attack that is called length extension attack that affect the SHA-256 function. So what is length extension attack? So basically in length extension attack, knowing only SHA-256 of a message M but not the actual message M is still allow an attacker to calculate the SHA-256 of some extended message M concatenation N. So here the message is same and attacker can concatenate another message N and can produce the SHA-256. That's why to ignore this attack in blockchain double SHA-256 is used. Now what is the hash of Merkle root? So basically the leaf node are the Bitcoin transactions. Suppose there are 4 transactions. So leaf node will contain the transaction, then parent node will contain the hash value of transaction. Then this node will contain the hash value of these two values, and so on. So basically this is the hash value or hash root. So hash Merkle root is a compact representation of all transactions in a block. Suppose if you want to verify whether a special transaction is present in that block or not, then easily you have to check basically the hash Merkle root. Or if there is any change in any transaction, then you have to check the hash Merkle root. Now suppose there is, what will happen when there is odd number of transactions? For example, when the number of transactions is not a power of 2. Here there is only 3 transactions, Merkle tree of 3 transactions. Then what will happen? We will compute the hash of this hash value 2 times. It means we will compute H1 by hash of H10 concatenation H of 10. Now what is the benefit of using Merkle tree of transaction? Why not the hash concatenation of all transactions? Definitely there is a question, what is the benefit to use Merkle tree? We can create the hash of transaction T0, T1 and Tn-1 and so on. So what is the benefit? So reason behind this is, this enables the efficient membership proof of transaction within a block. Merkle branch required to prove the existence of a transaction has size big O log n, and in case of hash of all transactions, the size will be big O of n. Then the n times is the time of candidate block creation. This is the 256-bit target threshold. I will explain how this target threshold is determined. So now we will discuss about target threshold. So actually finding the hash value is very easy. For example, suppose this is the data and you have to find the double SHA-256. Then simply you can apply this hash function and you will get an output. But problem will be created when we will impose some restriction. For example, suppose I am including the restriction that is starting 100 bit or 150 bit. So basically this is 256 bit. So suppose I am imposing a restriction that is starting 100 bit must be 100. Starting 100 bits must be 0. So in this case, finding a data such that output gives a hash value will be in such a way that static 100 bit is 0 will be difficult. So that is called the Bitcoin mining. So what we will do, or what miners do in this case, there is a nonce value. Miner first puts the 1 in place of nonce. Miners put 1. Then he will get some hash value, and then miner will check the condition is satisfied or not, whether starting 100 bit is 0 or not. If starting 100 bit is not 0, then the miner will update this nonce, and in place of 1, miner will put 2, then 3, then 4. So in this way, miner will change this nonce value and try to find a hash value which satisfies some condition. After some time, this target threshold is changed. So basically, the process of finding nonce such that double SHA 256 hash of a block header is less than or equal to target threshold is known as mining, and who finds this nonce is called miner. And it is clear that this nonce value is a integer value. You can see in the blockchain network. So basically this is the nonce value. So miner find this nonce value by one putting value 1, 2, 3 and so on. So this nonce value is an integer value. So for every block this nonce value will be different. For example, suppose I am opening this block. So for this block nonce value will be different. So you can see here nonce is different value. So finding nonce is not an easy task at all. This is very tough work, and this takes too much computational power. So basically double SHA 256 is used to find the hash of previous block. Now suppose the target threshold is T. So the probability that the block header hash falls below the target threshold for a trial n nonce is T plus 1 by 2 power 256. So if a miner will apply this hash function on this data, then the probability that miner will find a suitable nonce, to finding a suitable nonce, the probability is T plus 1 divided by 2 power 256. So modeling each try by the miner as a Bernoulli random process with success probability P, the average number of trials required to find a block header hash below the threshold is 1 by B. For example, the n bit field on January 1, 2017 was T is equal to 2 power 168. So basically 168 was the threshold value. So on January, the starting 168 bit must be 0. So in this case, the average number of trial required was approximately 2 power 70. So to find a suitable nonce, miner has to apply 2 power 70 times hash function on this data. And this number is very large. This is not easy at all. So the rate at which computing device can calculate block hashes is measured in mega hashes, that is equal to 10 power 6 hashes per second, giga hashes that is equal to 10 power 9 hashes per second, or tera hashes that is equal to 10 power 12 hashes per second. So definitely there are some limitation on our computer. Our computer can compute limited number of hash functions per second. So a typical PC can calculate hashes at a rate less than 100 megahash per second. And to calculate 2 power 70 block hashes, a PC operating at 100 megahash per second will require more than 3 lakh years. So in this way, finding nonce value or mining Bitcoin is not easy. Many miners join their computer system and try to find the nonce value. That is called mining pool. And nowadays, mining is done using ASIC, application specific integrated circuit, designed especially to compute double SHA-256 function in parallel. So to finding nonce value, I mean, there are many miners available in Bitcoin network there, and they try to find the suitable nonce. You can see in the network, there are many miners. So this is the mining time. And this is the miner name. For example, this block was mined by btc.com. You can find the detail of btc.com here. So this is a Bitcoin miner. So there are many miners. This is the anonymous miner, Beyond's pool. There are many miners available in the Bitcoin network, and any can join the Bitcoin network. That's why blockchain or Bitcoin is called decentralized. Anyone can join this network. If you have a computer system that can compute many hashes per second, then you can join this network. You can download the complete blockchain and you can do the process of Bitcoin mining. So there are many miners. You can see the detail from here. Now, how is target threshold value is chosen? So as of November 2023, the total hash rate available across the whole Bitcoin network is 68 terahashes per second. So complete Bitcoin network means the computational power of all miners. If you will join the all computational power, then in November 2023, the Bitcoin network has 68 terahash per second computational power. So the Bitcoin protocol specifies that average time required to mine a valid block should be 10 minutes. It means within a 10-minute, miners will be able to find a valid block in blockchain technology. So in this way, the target threshold is chosen. So what we do in normal banking system, now we will discuss the working procedure of Bitcoin. So in normal banking system, we completely depend on bank. Suppose I have a account in State Bank. So suppose this is the State Bank. Now suppose I want to transfer some value to Bob. So what I will do, I will log in my State Bank account. I will create a transaction. I will enter this person's account number. Then I will enter the amount and I will create a transaction. And this transaction will be verified by this bank. So there is a trusted third party. Here SBI is trusted third party. This bank can verify this transaction or this bank can cancel this transaction. So here or in nowadays in banking system, we are dependent on bank. So to remove this problem, cryptocurrency or Bitcoin was introduced. So basically in Bitcoin, there is no central authority. Here this transaction is verified by this bank, but in Bitcoin, the transaction is verified by anyone can verify this transaction. Each miner can verify this transaction. There is no central authority. So in Bitcoin network, this transaction is verified by a Bitcoin network. I mean, there are many miners who can verify these transactions. There is no central authority. So now, suppose here Alice has created some transaction T1, T2, T3. So this transaction will be collected in a transaction pool. And what these miners will do, miners will collect some transaction from transaction pool and put in a block and will try to find a nonce value. Suppose some miner is able to find a suitable nonce, then he will publish that block to the Bitcoin network, and each miner can verify that the nonce value is correct or not. And if the nonce value is correct, then that block will be connected to the blockchain. So finding the nonce such that double SHA 256 is less than target threshold is called Bitcoin mining. And if a miner is able to find suitable nonce, so that is called winner, and he gets some reward as a Bitcoin. So you can see here, for example, in this block, miner will get a reward point 6.25 Bitcoin. So after 4 years, this reward value will be reduced. So there is an upper cap in Bitcoin network. There can be maximum 21 billion Bitcoin network in blockchain technology or in Bitcoin network. So you can see here, this is the maximum supply in Bitcoin network. 21 million Bitcoin can be mined in this network. So here the winner miner will get reward point. Now there is forking situation. Forking situation means, suppose this is the existing blockchain. Now suppose at the same time two miners find nonce for two different blocks, then these two blocks will be connected to this block. But suppose some few miners are working on this block and majority of the miners are working in this block, then this chain will be longest. Suppose here 2-3 miners are working, but more miners are working on this chain. So this chain will be the longest chain. So this is the rule in blockchain or in Bitcoin network, that longest chain sustain. Longest chain is the valid blockchain. So in Bitcoin, decentralized peer-to-peer collaborative network, and the goal is all peers should agree on a sequence of transactions. This is one of the property of Bitcoin, that publicly verifiable, as the complete ledger and the hash function is public, as already I have shown you, that blockchain is publicly available, so anyone can verify the Bitcoin transactions. This is the...
Yes, sir.
Yeah.
Sir?
Yes.
Sir, there is a query from YouTube chat box from faculty R. Rajendra Prasad, sir.
Yeah.
The query is, can we generate private key? Can we generate private key gen?
Yeah, definitely private key and public key can be generated. But in blockchain technology, there is no encryption technique. All data is publicly available and only hash function is used and digital signature is used. No encryption, decryption is used in blockchain technology. Okay, only two cryptographic primitive is used in blockchain technology. First one is hash function and digital signature. No encryption, decryption is used in blockchain technology. And this is the beauty of blockchain. Actually, encryption decryption is used in cloud computing. This is one of the difference between blockchain and cloud storage. But suppose if someone wants to store some encrypted data in blockchain, then it's okay, no problem. A person can store encrypted data on blockchain. There is no issue. He can generate his own public key, secret key, and can store the encrypted data on blockchain. There is no issue. Okay, am I clear? Okay. So in Bitcoin, this is temper evident. I mean, tempering is not possible. You can see everything in blockchain, where you can see every transaction is publicly available. There is no encryption or decryption. You can see here all transactions are publicly available. Everything is publicly available, but you can't change, you can't modify any transaction or any data, because each block is connected with each other with the help of hash function. And if you will suppose some attacker is trying to change this hash value, then we can easily identify that there is a tampering. And longest chain sustained in blockchain network. So basically the Bitcoin is eventually consistent as the longest chain, eventually sustained as the main chain. So this is the all property of Bitcoin network. First one is decentralized, publicly verifiable, tamper resistance, and eventually consistent. So one of the major difference between blockchain and cloud is that blockchain is decentralized. There is no central authority, but in cloud, there is a central authority. I mean, there is a service provider. For example, suppose I am using Dropbox as a data storage. So owner of Dropbox is the whole power. He can do anything with my data. But in blockchain, there is no central authority. And this is the overall scenario of Bitcoin transactions step. Suppose here, Bob wants to transfer some Bitcoin to Alice. Then first he will do what first Bob will do. Bob initiate a Bitcoin payment using third-party wallet software. There is a Bitcoin wallet software just like our banking system. We have SBI app or PNB app, and with that app we can create transactions. So in Bitcoin network, Bob can create Bitcoin payment with the help of third-party wallet software. And this and other pending transactions are broadcast on the global Bitcoin network. In normal banking system, once we create the transaction, that transaction is verified by the bank. But here, the transaction will be verified by miners. What miners will do? Miners collect few hundred transactions and combine them in a block, because there is a size limitation on each block. So only few number of transactions can be present in a block. So miners collect a few hundred transactions and combine them in a block. After that, miners compete to process the block, looks for a correct proof of work every 10 minutes. So a block is mined in the network. So basically in fourth step, miners try to find the nonce value. That is an integer value, and finding nonce value is not an easy task. Miners should have too much computational power to find the nonce value. Once a miner will be able to find the suitable nonce, so that miner will be winner, and winner miner disseminate the new block to the entire network, recording the transaction in the blockchain, and it is rewarded with newly minted bitcoins. And Alice can use her wallet software to see whether the Bitcoin has arrived or not. But in Bitcoin, there is a problem. I mean, to verify a transaction, Bitcoin network takes at least, 10 minutes. So suppose if you go to a shop and you purchase something with the help of Bitcoin, and after the Bitcoin transaction, you have to stay there for 10 minutes. So this is the major disadvantage of Bitcoin. transaction. A Bitcoin transaction will be verified within 10 minutes. So now, second cryptographic primitive is multi-signature. So basically, multi-signature is used to create signature in Bitcoin wallet. So what is the use of multi-signature? So suppose three or more person is associated with a Bitcoin wallet, that is called multi-sig wallet. So suppose there is a multi-sig wallet and three people is involved with that wallet. Now suppose these three people is creating a Bitcoin transaction, then there is a need of three signature. So suppose Alice, Bob, Carol wants to sign a transaction, then in blockchain we have to store three signatures: signature of Alice, signature of Bob, and signature of Carol. So in this way, this will increase the size of blockchain. But our goal is to reduce the size of blockchain. So basically, multi-signature is used to reduce the size of blockchain. What happens in multi-signature? In multi-signature, there is an algorithm that will concatenate all these three signatures and produce a single signature. And the size of that single signature is equivalent to the signature of individual signers. So in this way, we can reduce the size of blockchain with the help of multi-signature scheme. Now, there are many multi-signature schemes available, but there are some problems. The multi-signature scheme based on pairing based, I mean, nowadays, people are working on post-quantum cryptography. So till now, there is no efficient post-quantum secure multi-signature scheme which is secure in standard model. We have proposed a multi-signature scheme which is secure in post-quantum cryptography, but that scheme is based on random oracle model. So till now, there is no multi-signature scheme which is post-quantum secure and secure in standard model. So if you are interested in multi-signature scheme, then you can work in this direction. You can try to construct a post-quantum secure multi-signature scheme, which is secure in standard model. And for reference, you can visit my Google profile. You can see there is a paper, efficient multi-signature scheme using lattices, and this work has been published in the Computer Journal, which is published by Oxford University Press. So in future, if you have any problem, you can contact me. So this is related to multi-signature. Now we will discuss about cloud computing. So definitely blockchain and cloud has many differences. As already I have said, there is no encryption decryption process in blockchain, but in cloud there is encryption and decryption. For example, the Dropbox is using AES encryption scheme to encrypt our files. Also, a major difference between cloud and blockchain is decentralized, but cloud is centralized. But definitely, both have their own benefit. So, cloud computing is a way of storing and accessing your information online. You don't need to buy or maintain a server to store data because it's all stored in the cloud. You can access the data from anywhere as long as you have an internet connection, making it easier to work remotely. With cloud computing, you don't have to worry about backing up files because it automatically back up everything and is available whenever you need it. So there are many cloud computing services. First one is software as a service. So software as a service, also known as cloud-based software or cloud application, is application software that is hosted in the cloud and that user access via a web browser, a dedicated desktop client, or an API that integrates with a desktop or mobile operating system. In most cases, software as a service users pay a monthly or annual subscription fee. Some may offer pay-as-you-go pricing based on your actual usage. Second computing service is platform as a service. So platform as a service provides software developer with on-demand platform hardware, complete software stack, infrastructure, and even development tool for running, developing, and managing application without the cost, complexity, and inflexibility of maintaining that platform on premises. With platform as a service, the cloud provider hosts everything: servers, network, storage, operating system, software, middleware, database at their data. So, third computing service is infrastructure as a service. So, infrastructure as a service provider on demand access to fundamental computing resources, physical and virtual services, networking and storage over the internet on a pay as use go basis. So, infrastructure as a service enables an user to scale and sync resources on a needed basis, reducing the need for high upfront capital expenditure or unnecessary on-premises or owned infrastructure, and for overbuying resources to accommodate periodic spikes in the usage. In contrast to SAS and PS and even newer PS computing models such as containers and serverless, IS provider the user with the lowest level control of computing resources in the cloud. So in serviceless computing, also called simply serverless, is a cloud computing model that offloads all the backend infrastructure management tasks, provisioning, scaling, rescheduling, patching to the cloud provider, freeing developers to focus all their time and effort on the code and business logic specific to their applications. What is more, serverless runs application code on a pay request basis only and scales the supporting infrastructure up and down automatically in response to the number of requests. With serverless, customer pay only for the resources being used when the application is running. They never pay for ideal capacity. Now, as I have said, encryption is used in the cloud. So nowadays, people are using symmetric key cryptography because that is efficient. Symmetric key cryptography is efficient than public key cryptography. But there is some problems in symmetric key cryptography. So basically in symmetric key cryptography, there is a problem of key sharing. So to remove that problem, public key encryption was introduced, in which there is a key generation algorithm, encryption algorithm, and decryption algorithm. So basically, key generation algorithm takes a security parameter and generates the public key and secret key. Then encryption algorithm takes the public key and a message M and gives the ciphertext, and decryption algorithm takes the secret key and the encrypted message and gives the plain text message M. And we said that this encryption scheme is correct if the decryption is giving the correct message with probability 1. So when we store data on cloud, so we try to encrypt that data and upload the encrypted data on cloud. So there are many encryption techniques. There are many symmetric key cryptography, public key cryptography that can be used to encrypt the data, and you can store that encrypted data on cloud. But there is some problem. Suppose you want to do the computation on encrypted data. For example, suppose you have two numbers. Suppose you have two numbers 5 and 10. You have encrypted the value 5 and 10 and uploaded the encrypted value on cloud. Now suppose you want to find the sum of 5 and 10. Then can you do the summation part with the help of cloud without revealing the value of 5 and 10? So yes, with the help of homomorphic encryption, you can do computation on encrypted data. So with the help of homomorphic encryption scheme, you can do computation on encrypted data. So basically, homomorphic encryption is a public key encryption scheme that contains 4 algorithms: key generation, encryption, decryption, and eval algorithm. So basically, key generation algorithm will give you public key, secret key. Then encryption algorithm will give you the ciphertext, and decryption algorithm will give you the plain text message after taking secret key and the ciphertext. Here, what this evaluation function does. So basically, this evaluation algorithm is run by the cloud. So basically, this algorithm evaluation function algorithm takes the public key and a circuit C. You can call this circuit or a function, because every function can be converted into a circuit. So basically, this C is a circuit or a function. In simple words, you can see C is a function that you want to apply on the encrypted data C1, C2, and CT, where CI is the encryption of MI. So basically here, same public key is used to encrypt the message MI. And this will give you the evaluated value psi. So this is not actually C of M. And this scheme is called correct if for any key pair, public key and secret key, if suppose phi is the value of C of M1, M2, MT that you want to compute with the help of cloud. Suppose you want to compute the C of M1, M2, MT with the help of cloud. Here, you will get this value after the decryption. When you will decrypt this evaluated message, you will get C of M1, M2, MT. So without giving the original message with the help of homomorphic encryption, you can compute the value phi. And there are many applications of homomorphic encryption. For example, you can apply homomorphic encryption in private information retrieval or even in cloud computing. Suppose this is the application of homomorphic encryption in cloud computing. Suppose there is a user and this is the server. Now suppose user want to store the encrypted data xi. So here user will encrypt this data xi and upload this encrypted data in the cloud. Now suppose this user wants to compute f of xi, and this user wants to compute f of xi with the help of cloud server, because suppose he don't have the computational power to compute f of xi. So he can compute f of xi with the help of cloud server. Also he don't want to reveal the value xy, because here the cloud is untrusted source. So with the help of eval function, this server will run an evaluation function. This evaluation function takes the encrypted value and function f and will give you the encryption of f of xi. And after applying decryption algorithm, this user can find the value of f of xi. So in this way, you can apply homomorphic encryption in cloud computing. Now, there are many types of homomorphic encryption. For example, fully homomorphic encryption, partial homomorphic encryption. For example, RSA is partial homomorphic encryption. So in fully homomorphic encryption, there is no restriction on the function f. This function f is independent of the encrypted ciphertext value. Also, there is multi-key homomorphic encryption scheme. So what is multi-key homomorphic encryption scheme? Basically, nowadays people are working on multi-key homomorphic encryption scheme. So basically, in this homomorphic encryption scheme, there is some limitation. What is the limitation? Here, data is encrypted with the same public key. But in multi-key homomorphic encryption, data can be encrypted with the help of many public key. For example, suppose there are many users, suppose there are n users. Each user has their own public key. So with the help of multi-key homomorphic encryption scheme, people can do computation on encrypted data that is encrypted with different public keys. So now we will discuss the overall difference between cloud computing and blockchain. So basically, cloud computing can be considered as an internet-based hosting service where providers offer storage space and computer power over the internet. While a blockchain is a decentralized ledger that maintains a continuously growing list of data record secured from tampering and revision. With cloud computing, you can store your information in one centralized location. But if that location is, suppose someone has hacked that centralized location, then your data will be removed. But in blockchain technology, you can store data in multiple locations worldwide. Every node is storing a copy. For example, in blockchain technology, every miner have the copy of blockchain. As opposed to blockchain's peer-to-peer design, cloud computing heavily relies on leaving many intermediary companies, but in blockchain does not require any third-party service provider to function, and anyone can control everything within its network. So in cloud, there is a centralized data storage. Cloud computing stores all your data in one central location, making it vulnerable to being hacked or tampered with. This is the disadvantage of cloud computing basically. So physical hardware failure, with physical hardware failure such as power outage or server clashes, you can lose access to your data, resulting in high business downtime and an interruption in productivity. Lack of security, cloud computing systems are more vulnerable to attack due to their centralized nature. Cost efficiency, when it comes to cost efficiency, cloud computing is typically much more expensive than implementing a blockchain solution at the experience level. Single point of failure, due to cloud computing being centralized and in one location, your business would be affected worldwide if there is an outage. So thank you. If you have any query, you can ask me. So one open problem in cloud computing is that you can work in the direction of multi-key homomorphic encryption scheme. Nowadays people are working on multi-key homomorphic scheme that is secure against quantum computer. So if any of you have any doubt, you can ask me. Yes, sir. Yes, sir. Yeah, actually, to integrate IoT devices, there is a new concept that is called edge computing. So with the help of edge computing, there are many edges near to IoT devices, and that helps to do computation for IoT devices. So with the help of edge computing, you can integrate cloud or blockchain with the help of IoT devices. Yeah.
Thank you, sir, for the informative talk on blockchain and cloud computing. Thank you, sir, for your insightful talk on blockchain and cloud computing technology. I would like to express my sincere thanks for your enlightening talk. Your insights have broadened us for understanding these technologies. Thank you for sharing your time and expertise with us, sir.
Thank you. Thank you. If any of you have any doubt or any query related to research, any of you can contact me through my email ID or WhatsApp. Thank you so much. Thank you. Thank you. Thank you, sir.
Sir, good morning, sir. Good morning, sir. Sir, we will start in 2 minutes.
Sir, is my voice audible? Okay, okay, sir.
It is my distant pleasure to introduce our resource person, Dr. Chandra Sekhar Sir, an accomplished academician and a distinguished assistant professor in the Department of Computer Science and Engineering at the University College of Engineering, Kakinada. Sir is a beacon of knowledge and experience in the field of computer science. Sir earned his bachelor's degree in electronics and computer science and engineering from Koneru Lakshmaya College of Engineering in 2005. Subsequently, Sir pursued his master's degree in computer science and engineering from Veluru Institute of Technology in 2008, showcasing Sir's commitment to continuous learning. In 2020, Sir successfully obtained his doctorate of philosophy in the dynamic domain of Internet of Things from JNTK, making a significant milestone in his academia journey. Sir has over 13 years of teaching experience and approximately 10 years dedicated to research. Sir expertise encompasses wireless sensor networks, IoT, machine learning, data science, and artificial intelligence. Sir has significantly contributed to the academic community with more than 20 research papers published in various peer-reviewed UGC Care, Web of Science, and Scopus indexed journals. Sir's commitment to advancing the frontiers of technology and sharing knowledge is truly commendable. Thank you, sir. Thank you.
Thank you, sir, and thank you, Aisha, for introducing me. Is my voice audible, sir? Sir, is the screen visible, sir? Thank you, sir. Good morning to all the participants. And this is the last session of the 1 week online faculty development program on the role of big data and cloud in the era of transformation. And this is the last session. So I'm going to handle a topic of research aspects in the cloud computing and big data. And this is about me, and Aisha has given an introduction about me. And this is the agenda which I'm going to discuss in today's session. The first topic what I'm going to discuss is introduction to cloud computing, where we'll have a very brief discussion on cloud computing, and then a very simple slide of history of cloud computing. And the third topic is where we are going to concentrate more, where we are going to discuss the various research areas in the cloud computing. And after completion of this cloud computing, we move to the introduction of to big data and then history of big data. Everything will be in a just simple manner, but research aspects in the big data will be discussing elaborately. So this is my agenda for today's session, and let's begin the cloud computing. So this is the slide of introduction to cloud computing, and we know that the cloud computing is internet-based computing, where in order to provide the services or in order to use the services of the cloud, we require the internet. Without internet, the cloud computing will not work. And the cloud computing can be taken as a fusion of the traditional networking technologies and traditional computing technologies such as grid computing, distributed computing, and the parallel computing. We can also say that this is the third revolution of the IT industry, where the development trend of the IT industry has been changed in a different sequences. For example, the IT industry previously was from hardware to software, then we have software to services. This is where the cloud computing comes into existence. So previously we used to have the softwares installed in our own systems. But right now we are going to get the software or hardware, whatever it may be, as a service. And the IT industry has moved from distributed service to the centralized service. This is the reason why the cloud computing is called as third revolution in the IT industry. And the core concept of the cloud computing is reducing the processing burden on the user terminals. So how they are going to reduce the burden on the user terminal is they are going to make the user terminals very simple that they only handle the input and output devices. And whenever we require the powerful computing capacity or computing capability, we just depend upon the cloud. We take the services of the cloud. This is how the cloud computing has changed the. This is the core concept of the cloud computing. And there are so many service providers which provides the cloud computing services, and these are the tech giants we have, that is Amazon, Microsoft, Yahoo, Salesforce.com, Google. There are so many IBM, HP. There are so many cloud service providers, but the Salesforce.com is the first company that has identified the importance of the cloud computing. And we have so many deployment models like public, private, hybrid, and community. We all know about this one. I'm just giving, since it is the last session, I'm just giving a gist of what we have learned till date. Deployment models, the public cloud. Here in the public cloud, multiple customers share the computing resources provided by a single service provider. So the customers can quickly access these resources and they can pay for what they have utilized. Though the public cloud has very good advantages, it also has the hidden danger of security and the quality of service. It cannot provide that much of quality of service, and there are some regulatory compliances also. An example of the public cloud is MS Azure, that is Microsoft Azure, Google App Engine. Similarly, the private cloud is owned by a company, so the policies and everything will be given by that organization itself. And here we can see that with respect to or in comparison to the public cloud, we can achieve highest security in the private cloud. We can have our own policies, we can have our own quality of services, we can have the compliance. So private cloud is more secure when compared to that of the public cloud. Example of the private cloud is Eucalyptus. This is one of the cloud we have. And the next deployment model is the hybrid model. As the name itself suggests, that it is a combination of both public and private. So it enables the enterprise to uh, run the small works in the private cloud, and whenever we want to have the intensive computing resources, we just depend on the public cloud. Example, a best example for this hybrid cloud is Amazon Web Services, which is very predominant in today's market. And finally, we have another deployment model which is called as the community cloud. As the name itself suggests, that it is a community, that means it is a group of organizations. These group of organizations, they come and form a community, and they jointly construct and share the same cloud infrastructure. And all the organizations that are in the community will have their own policies. They have their own requirements, and they have their own values and concerns. So an example, a best example of this community cloud is the Facebook. So this is all about the introduction, and we can also say that it is a pay-per-use model. The pay-per-use model in the sense that the user has to pay for what he has used. He doesn't need to pay for what he has not used. And it is on-demand service. That means whenever we require a service, then only you can ask the cloud service provider, so that we can get it, we can get the service, and we can pay for that particular scenario itself. And there are so many sectors that are using this cloud computing, like banking sector is using this cloud computing, healthcare sector, education, and there are so many sectors which make use of this cloud computing. And this is very important that in cloud computing we always discuss about the service models. For example, we have SaaS. Basically, we have only three important service models. One is called as SaaS, which is a software as a service, and the second one is PaaS, platform as a service, and IaaS, which is infrastructure as a service. Coming to software as a service, we can say that SaaS can be described as the process by which the application service provider provides different software applications over the internet. So here we are going to get various softwares as a service over the internet itself. This we have discussed in the previous slide also. This makes the customer to get rid of installing and operating the application on own computer, and also eliminates the tremendous load of software maintenance. An example of SaaS includes Salesforce.com and Google Apps. Similarly, coming to the platform as a service, here PaaS is the delivery of a computing platform. For example, you can deliver a operating system as a service, right? And which is very beneficial for the developers, IT managers, and end users. There is no need to software downloads, and there is no need to installation also. So this is how the platform as a service benefits the developers, IT managers, and some end users also. An example of PaaS includes the Google App Engine, Microsoft, Azure, etc. Similarly, infrastructure as a service is very important. As a service refers to sharing of hardware resources for executing services using virtualization technology. Many of the people have a misconception that cloud computing means we are going to get only the software as a service, or we are going to get the other things as a service. But in the cloud computing era, we can also get the hardware as a service also, and this is achieved by a very important technique in the cloud computing, which is called as virtualization. So we can have the servers as a service, we can have the network as a service, we can have the storage as a service, and the best examples for this infrastructure as a service includes the Amazon EC2, where EC2 stands for Elastic Cloud Computing. And similarly, Amazon S3 and GoGrid, all these are the examples of infrastructure as a service. Now coming to the history of the cloud computing, people say that there are so many references in the websites, and there are so many things that we come across in the internet, and people say that the cloud computing was invented by Joseph Carl Robinet Licklider in the 1960s. He has envisioned a world such that people and data are connected from anywhere and at any time. But later in 1961, John McCarthy is called as the father of computers. And he said that the computing can be sold as an utility, as if the water is sold, as if some entity can be sold. He envisioned that the computing can also be sold as an utility. But at the time, people doesn't believe that this new technology is not up to the mark. So they have not adopted. People are very reluctant to adopt this new technology. But in 1997, a scientist called Ramnath Chellappa, he has coined this particular term called as cloud computing. So the father of cloud computing is John McCarthy, and the term cloud computing is coined by Ramnath Chellappa. Right? And the first company that has adopted this cloud computing technology is the Salesforce.com in the year 1999, and from then onwards, many industries they started adopting this technology. That is, the Amazon Web Services they have started utilizing this cloud computing in the year 2002, and similarly, Google started its cloud computing in 2009. Similarly, Microsoft in the year 2009 itself. And there are so many IBM, HP, there are so many things that come across companies that has adopted this cloud computing technology. And one of the best data center, largest data center uh, in the world is China Telecom Inner Mongolia Information Park, which costed around $3 billion to establish this particular information park. And it occupies a space of around 1 million square meters, which is equal to around 220 football grounds. And it takes a huge amount of electricity to maintain the data center itself is very costly thing, right? So this particular information park, Mongolia Information Park, it utilizes around 150 megawatts of power every day. So this is just a history of the cloud computing. Now, these are the popular cloud computing platforms. We have Salesforce, GCP, EC2 from Amazon, Amazon Web Services, Eucalyptus, OpenNebula, IBM Cloud, Oracle Cloud, Nimbus, Azure from Microsoft, Rackspace Cloud, DigitalOcean, and Abbey Cloud. So many cloud computing platforms are available to work on them. And if we cannot afford to work on the real cloud computing platforms, we can make use of the simulators also. Like we have cloud analyst simulator, we have network cloud simulator, and the green cloud, Cynic, InnoSim, Cloud Sim. All these are the simulators which mimics the functionality of the cloud, so that a researcher, if he cannot afford uh, to pay for the real cloud computing environment, he can simply work on the simulators also as a researcher. And here comes the cloud computing issues. We should discuss these cloud computing issues before going into the actual research areas. The reason why we should discuss these issues is these issues will help us to identify the research gaps. So whenever you try to find some research gap, first of all, what we have to do is we have to find what are all the issues that come across with that particular technology. So we are going to discuss about these cloud computing issues, and we can see here that we have so many terminologies, like we have the issue of security in the cloud computing, we have the issue of privacy in the cloud computing, we have legal issues, we have reliability issues, we have interoperability issues, and similarly open standardization, compliance. These are all the various issues. And when coming to the research gap and the research problems in the cloud computing, most of the people concentrate on the security. As an academician, we concentrate on very few topics like security, privacy, interoperability, and these legal issues and compliance, standardization. These are all the issues that are handled by the business people, not by the academicians. So the organization, there are some standard organizations which make use of they're particularly established, or they have been implemented to implement these standards. They have been established to implement these standards, and there are some organizations they can handle the legal issues of the different countries. We will come across all these topics one by one. So, as an academician, as a researcher, we always concentrate on the security and privacy. So, most of the research from the academicians end will come across this security and privacy. So, coming to the security, somebody may ask a question like, where is my data more secure, whether it is on the local hard drive or on the servers? So the answer for this question is, some people they argue that customer data is more secure when it is managed internally. That means when it is kept in the local system or the local server. But there are some people who argue that the customer data can also be secure in the cloud also. Why? Because most of the cloud computing providers, they have a strong incentive to maintain the trust, and as such they employ a higher level of security. However, in the cloud, the data will be distributed over these individual computers. So cloud is not a single computer. It is a combination of different computers. It is a combination of different servers, different infrastructure, which is located in various locations. For example, one data center may be in India. Some other data center is located in America. Another data center is located in Europe. Like that, it is a distributed environment where our data, what we store in the cloud, may reside in any of these data centers. And we don't know where the actual data, where the base repository of data is ultimately stored. So in this situation, we may come across two types of data thefts. One is from the outsider theft and another is from the insider theft. Outsider theft, the best example is the hacker. A hacker can invade virtually any server and he can get the data. But insider theft is a theft that happens in the organization itself. That is, uh, for example, an employee, he may do it intentionally or he may do the theft of data accidentally, intentionally and accidentally. So there are some statistics that show that one third of the breaches that result in the organization is from the stolen or lost laptops only, and accidentally exposing data on the internet, and this constitutes almost 16% of data theft, which is from the insider. So the outsider theft is around some 84%, and the insider theft happens with around 16%. So security, providing security for the customer data is a very important aspect in the cloud computing, and we don't wonder that most of the research happened in the security itself. If you take any research area in the any researcher who has done research in the cloud computing, they always discuss about this security. They always discuss about this privacy only. And coming to the privacy, we know that customer data is very important. And when compared to that of the traditional computing model, cloud computing utilizes the virtual computing technology, virtualization, where users' personal data may be scattered in various virtual data centers rather than staying in the same physical location. And this scattering of data can happen across national borders also. Previously, also, we have discussed the same issue. And at this time, the data privacy protection will face a lot of issues regarding the legal systems also. Let us say that we have a country, India, and we have another country in Europe. Let us say we have two data centers in India and Europe. When a security breach occurs, which legal issues we need to handle? That means whether we need to go with the legal issues of the India or whether we need to go with the legal issues of the European countries. This is a very prominent area, but as far as my knowledge is concerned, this is not the issue related to a academician. These legal issues will be handled by the cloud service providers itself. Similarly, on the other hand, users may leak hidden information when they access cloud computing services. Attackers can analyze the critical task depending on the computing task submitted by the users. Similarly, reliability is another topic. Reliability means even this particular case comes with the traditional computing also. Servers in the cloud have the same problem as our own resident servers. The cloud servers, they experience the downtimes and slowdowns. So sometimes you may come across a situation where your cloud computing is not responding, or your cloud server is not responding. That means it is down for some amount of time. So in the cloud service providers model, once you select a particular cloud service provider, you are just locked. You're just locked, and this brings a potential business security risk. So reliability of the customer on a service provider, cloud service provider, is very important. So before choosing a cloud service provider, you should, as a customer, you should always go through the different aspects, how far the cloud service provider is providing the reliability of these things. And coming to the legal issues, as we have discussed earlier, let us say that we have two different countries. Those countries will have different legal policies. So when a security breach happens, which legal panel we need to discuss, we need to take into consideration. This is one of the major issue when compared with respect to this cloud computing. Similarly, open standards. We know that standards play a very important role and they help us for the interoperability. So open standards are critical to the growth of the cloud computing also. Most cloud providers, they expose the APIs which are well documented but also unique to their implementation, and thus they are not interoperable. So in order to have the interoperability, we should have the standards that are defined and they should be well documented. So there are so many consortiums or the organizations that are working to develop the standards. For example, we have the Open Cloud Computing Interface and we have Open Cloud Consortium, which are continuously working to develop consensus on early cloud computing standards and practices. Similarly, compliance is another issue, cloud computing issue, where there are numerous regulations pertaining to the storage and use of data require regular reporting and audit trails. Cloud providers must enable their customers to comply appropriately with these regulations. So there are so many regulations where a cloud service provider or where the customer has to follow, and if the customer follows those regulations, then only we can have the flavor of the cloud computing. We can have the very good flavor of the cloud computing. So after looking at these different issues, cloud computing issues, let us discuss the cloud computing security architecture. As I told in the earlier slide itself, we have so many issues regarding this cloud computing, but most of the research from the academicians and from the industries, they happen in the security itself. That is the reason why we are going to discuss about this cloud computing security architecture. So as you can observe here, we have four different types, four different layers. Starting from down, we have the data center layer, and then we have virtualization layer, and then we have service provider layer, and then we have user layer. User layer, we are not going to bother about it. Why? Because in the user layer security, we are going to provide the browser security, etc. But the remaining three layers are very important when you want to provide the cloud computing security. For example, security within the cloud computing is a very worrisome issue because of the fact that devices used to provide services do not belong to the users. They belong to the cloud service provider. The users have no control. They doesn't have any knowledge of where their data is stored. They cannot estimate what could happen to their data. So these are all the security risks that are present in the cloud computing environment. So this is a great concern in cases when users have valuable and personal information stored in the cloud computing service. Users will not compromise. Remember that the customer will not compromise on their privacy. So cloud computing service providers must ensure that the customer's information is always safe. But the security provision is becoming increasingly challenging because when we provide a security development, there are always so many people or there are so many issues that figure out a way to disable the security and take advantage of user information. Coming to service provider layer, we have so many components under the service provider layer. We have the SLA monitor, where SLA stands for service level agreements, and we have the component for resource provisioning. We have a component for metering and accounting. We have a component for load balancing. We have a component for scheduling, dispatcher, and resource reservation monitor. These are all the various components that we have in the service provider layer. And various security issues that are raised in the service provider layer are security issue related to identity, security issue related to infrastructure, security issue related to privacy, how we are going to provide the security for auditing, and how we are going to provide the security for data transmission, and how we are going to provide the security with respect to the compliance. All these are the issues, security issues related to service provider layer. And coming to the virtualization layer, various components that are present in the virtualization layer are creation of virtual machines. So a component is there which can where we can make use of that component to create the virtual machines. Similarly, a component for monitoring, a component for metering, a component for issuing the operating systems. All these things are there. And when coming to the security issues in this virtualization layer, we have various concepts like VM sprawl, VM escape, infrastructure, how we are going to provide the security for the infrastructure, regulatory issues, identity management, access management, and legal issues. So there are so many topics on which we can do our research, but the thing is that a few topics are related to the academicians, and few topics are related to the industries, and few topics are related to the business persons. The high level authorities or the high level business persons has to take the decisions. For example, if you take the regulatory issues, regulations are not governed by the customer or the end user. They have to be designed by the high level business people, and they have to be provided to the customers. So there are so many issues we need to concentrate. Similarly, if you consider the next layer, that is the data center layer, we have various components like servers, CPUs, memory, and storage. And the various security issues that we need to provide in the data center layer are the physical security, secure data at rest, secure data at transmission, how we are going to provide the network security, how we are going to provide the server security. All these things are there. And as I told that there are so many organizations and industry consortia that are working on developing these standards, that are working on developing these regulations. For example, we have an organization called as CSA, which stands for Cloud Security Alliance. This is a non-profit organization formed to promote the use of best practices for providing security assurance within the cloud computing. Similarly, there is another organization called as OSA. OSA stands for Open Security Architecture. This is another organization which focuses on the security issues. They propose some patterns which are called as OSA patterns. And these patterns is nothing but an attempt to illustrate the core cloud functions, the key roles for the oversight and risk mitigation, collaboration across various internal organizations, and the controls that require additional emphasis. Similarly, there are other organizations like IETF. IETF, as we are very well known, that this IETF stands for Internet Engineering Task Force. And similarly, we have SNIA, which stands for Storage Networking Industry Association. All these organizations, they continuously strive for the development of regulations and standards, which help for the development of the cloud computing environment. Right. So this is the main topic of our today's session, that is the security issues in the cloud computing. We have gone through the scenario like this. First, we have gone through the introduction to cloud computing. Then we have gone through the history of cloud computing, which is a just vague discussion, and this is a very fluke discussion we have gone. And then we have gone into the cloud computing issues. So by discussing the cloud computing issues, then we can understand the research gaps, and we have identified that security plays very important role, and there is a very good research gap we can find in the security only. Then we have seen the security cloud computing architecture, where we have seen different layers and where we have seen different security issues we can address in various layers also. Now we are into the security issues in the cloud computing. So there are so many security issues in the cloud computing, like access to servers and applications. From here onwards, we can understand how we can identify the research gap. And in the final slide, I will just give the overview of what are all the various topics we can concentrate on for our research. And here the security issues in the cloud computing are access to servers and applications, data transmission, how we are going to provide the security in the form of data privacy, data security, data segregation, data integrity, network security, data availability, and virtual machine security. We come across this access to servers and applications. In the traditional data centers, administrative access to the servers is controlled and restricted by a person who is on premise, who is working as an employee of an organization. But in the cloud computing, administrative access is conducted via the internet, which increases the exposure and risk. It is extremely important to restrict this administrative access to the data. So data access issue is mainly related to the security policies. So the solution for this data access, who can access this data or who can access this server, is nothing but the policies. So you should design your own policies. If you are an organization, you decide or you design your own policies, and these policies, what they will do is they will make they'll you just give an idea of who can access the data and who cannot access this data. So data access issue is mainly related to security policies provided to the users while accessing the data. A small business organization can use a cloud provided by some third-party cloud service provider for carrying out its business process. Some organization will have its own security policies based on which each employee can have access to a particular set of data. The security policies may entitle some considerations wherein some of the employees are not given access to certain amount of data. These security policies must be adhered by the cloud to avoid intrusion of data by unauthorized users. For example, if you consider, that means we can see here that we are going to provide the policies which restrict the administrative access to data. For example, if you consider an employee database, how this employee database is secured in the small organizations and how it is secured in the large organizations is a best example which we can discuss. So if it is a small organization, most of the companies, the small companies, what they are doing is they are storing their employee information in a server which is called as lightweight directory access protocol. This is LDAP, which stands for LDAP. Similarly, they can also make use of the Active Directory, which is a segment that has the highest cloud application adoption rate. So with the cloud application, the software is hosted outside of the corporate firewall. Many times, user credentials are stored in the cloud application provider's database and not as a part of the corporate infrastructure. This means the software as a service customers must remember to remove or disable the accounts of employees that leave the company and create or enable the accounts that they are newly recruited. So we can say it as a newly recruited employees can be created the accounts. So what we can do here is the cloud application providers, CSPs, they can delegate the authentication process to the customer's internal LDAP or AD server so that the companies can retain control over the management of the users. So here, because of this LDAP and AD server, the small organizations, they are not going to give the management of the employees to the third party. They are going to retain the management of the users by themselves with the help of LDAP and AD servers. Similarly, in case of large enterprises, the management of users account as the adoption of single sign-on. So they make use of a concept called as SSO, which stands for single sign-on. where each employee will be dispatched with some different accounts to access different systems. This is the most predominant thing what we are coming across in today's scenario. So an employee of an organization can sit anywhere in this world and they can simply access the resources provided by the organizations. So if one wants to work on a research area, they can work on this LDAP and Active Directory servers, or else they can work on the SSOs also. So they can bring some new policies or they can bring some new methods to implement this single sign-on method. Similarly, for the data transmission, which is a part of service provider layer, this particular thing we are very much familiar that when you are transmitting the data from one location to another location, in order to provide the security during the data transmission, we make use of a concept called as cryptographic techniques, where we make use of encryption and decryption techniques, where encryption is done at the sender end and decryption is done at the receiver end. So encryption techniques are used for data in transmission. So we need to discuss about the authentication, where authentication is nothing but providing protection for data, where the data should go to the customer who wants to use it. For example, if I want to send data to X, the data should reach only X. It should not reach some other person. This is called as authentication, and that person can make use of that data by making use of the authentication, like passwords, everything. And similarly, integrity is another terminology that we come across in the cryptographic techniques. Integrity is the data is not modified during the transmission. So for this, we have two particular protocols. One is the SSL, secure socket layer or transmission layer, this one, SSL and TLS. So one can, as an academician, you can also work on this SSL and TLS. Although these protocols are well established protocols, you can take these protocols, you can tweak these protocols, and you can provide better security during the data transmission in the cloud computing. So here you can work on this SSL and TLS. Similarly, we have these are all the different terminologies that are related to the cryptography, like authentication, authorization, confidentiality, and integrity. So the research gap, what we have found in this slide is a researcher can work on this SSL and TLS protocols also. Next, coming to virtual machine security. Virtualization plays very important role in the cloud computing. We have discussed this in the earlier slides also. And this virtual machine security comes under the virtualization layer of the cloud computing security architecture. Virtualization is one of the main components of a cloud. Virtual machines are dynamic in nature. That means dynamic in nature means they can quickly revert to the previous instances in case of any damage happens. They can be paused, they can be restarted instantly, and they can be done. All these tasks can be done relatively easily when compared to that of the other technologies. Ensuring that different instances running on the same physical machine are isolated from each other is a major task of virtualization. So isolation is another important topic. This one is important research area where we can work on it, and for this you should have a great idea of good idea of the virtualization concept. For example, if you take VM sprawl, this is a new terminology we come across in these virtual machines. That means virtual machine sprawl. That means we can readily clone a particular server and they can be moved from one location to another location seamlessly. This is what is called as a VM sprawl. So the dynamic nature and potential for VM sprawl makes it difficult to achieve and maintain consistent security. So we are going to move the server from one location to another location very frequently. So it will be very difficult to achieve and maintain the security. So there are possibilities that vulnerabilities and configuration errors may be propagated unknowingly. We have two types of virtualization. So we can work on this full virtualization or para virtualization. Full virtualization is the entire hardware architecture is replicated virtually. Whereas in the para virtualization, an operating system is modified. A small part of the operating system is modified so that it can be run concurrently with other operating systems. And another research area in this particular slide, virtual machines, is this virtual machine monitors. In short, we call them as VMMs. It is nothing but a software layer which provides an abstraction of the physical resources used by the multiple virtual machines. So, as a software professional or as a researcher in the academia, you can work on this virtual machine monitors where you can provide a software that works well with these virtual machines. So the VMM provides a virtual processor and other virtualized versions of the system devices such as IO devices, storage, memory, etc. Many bugs have been found in very popular virtual machines. So we have so many virtual machines, machine monitors that come from tech giants like Microsoft and all these things. But most of the VMMs have some bugs. For example, if you take the Microsoft Virtual PC, which is one of the virtual machine monitor, and Microsoft Virtual Server, the MS Virtual Server is allowing a guest operating system to run the code on the host or another guest operating system, which should not be allowed. This is a vulnerability we have found in Microsoft Virtual PC. Similarly, if you consider the vulnerability in the VMware, there is a vulnerability that was found in VMware's shared folders, which grants users of a guest system read and write access to any portion of the host file system, which is very dangerous, right? So the file system should not be exposed to the guest people. Similarly, we have a vulnerability in the Zen VMM where the root users of a guest domain execute the arbitrary commands. So all these are all the vulnerabilities we found in the most predominant virtual machine monitors. So you can take a virtual machine monitor and you can simply what you can do is you can work on this virtual machine monitor and you can try to address all these things, the questions what we have asked. That means you don't allow the guest to access the host file system. You don't allow the root users of a guest domain to execute the commands. So these are the things we can address. Similarly, the current virtual machines monitors, what we have, they do not offer a perfect isolation. So you can take a virtual machine monitor and you try to implement a perfect try to develop a virtual machine model that provides a perfect isolation. Similarly, in the network security. So in the network security, we have different types of networks like shared network, non-shared network, public network, private network, small area network, and large area network. So the problems associated with the network level security comprises of DNS attacks, sniffer attacks, and issue that is relevant to the reused IP addresses. So in the domain name server, we know the advantage of domain name server. It performs the translation of a domain name to an IP address. Since the domain names are much easier to remember, hence the DNS servers are needed. But there are so many cases when we call a server by name, the user has been routed to some other evil cloud instead of one he has asked. To address this, DNS security measures like DNS SCC, which stands for Domain Name System Security Extensions, this particular protocol, DNSSEC protocol, reduces the effects of DNS threats, but still there are so many cases when these security measures prove to be inadequate, when the path between a sender and a receiver gets rerouted through some evil connections. So even though DNS attacks are there, even though we have the DNS security protocol that addresses this DNS attacks, this is not up to the mark. So as a researcher, you can take this DNS sec protocol and you can work on it to provide the required security. Similarly, sniffer attacks. Sniffer attacks are launched by applications that can capture packets flowing in a network, and if the data that is being transferred through these packets is not encrypted, it can be read, and there are chances that the vital information flowing across the network can be traced or captured. So a sniffer program, this is a program which can be attached to a network interface card, ensures that the entire traffic linked to the other systems on the network also gets recorded. So it can be achieved by placing the NIC in the promiscuous mode, and in this promiscuous mode, it can track everything. It can track all the data, it can track the flowing on the same network, it can track all the packets, everything is tracked by this NIC if it is kept in the promiscuous mode. So a malicious sniffing detection platform based on ARP and RTT. ARP stands for Address Resolution Protocol and RTT stands for Round Trip Time. They can be used to detect the sniffing system running on a network. So as a researcher, you can take these two protocols, that is ARP and RTT, Address Resolution Protocol and Round Trip Time, and you can work on it. You can design more efficient ARP protocol. You can design more efficient RTT protocol. Similarly, the last issue is the reused IP. Reused IP address issue have been a big network security concern. When a particular user moves out of a network, then the IP address associated with him earlier is assigned to a new user. This sometimes risks the security of a new user as there is a certain time lag between the change of an IP address in the DNS and the clearing of that address in the DNS cache. And hence, we can say that sometimes, though the old IP address is being assigned to a new user, still there are chances for the old user to access the data, which should be avoided. So one can work on this particular DNS cache hardware device, and they can make it efficient such that when a particular IP address is issued to a new user, immediately within no time, you have to remove the entry from the DNS cache. This you can work as a research gap. This is another research gap. So in this slide, we have seen three different research gaps. One, you can work on this DNS security protocol. You can work on this ARP. One, you can work on this RTT, and then you can work on the DNS cache. And coming to the data security. So to achieve the service of the cloud computing, the most commonly utilized communication protocol is HTTP, Hypertext Transfer Protocol. In order to assure the information security and data integrity, we make use of another protocol which is called as HTTPS, which stands for Hypertext Transfer Protocol Secure, and another protocol is Secure Shell, which stands for SSH. These are the most common adoptions we can use for the communications. So in a traditional on-premise application deployment model, the sensitive data of each enterprise continues to reside within the enterprise itself. So, but in the cloud computing, the enterprise data is stored outside the enterprise boundary at the service provider end. So the service provider has to adopt additional security checks to ensure data security and prevent breaches due to security vulnerabilities in the application or through malicious employees. So the solution is we have to make use of strong encryption techniques for data security, and we can make use of fine-grained authorization to control the access of data. For example, cloud service providers such as Amazon EC2, which stands for Elastic Cloud Compute, administrators do not have access to the customer instances and they cannot log into the guest OS. What EC2 administrators will do is EC2 administrators with a business need, they are requested to use their individual cryptographically strong security keys to gain access to the host. Similarly, if you consider this Amazon SS3, which stands for Simple Storage Service, by default, it is not encrypted. Users can encrypt their data before it is uploaded to the Amazon S3 so that it is not accessed or tampered with by any unauthorized party. So in this particular thing, we can work on this HTTP, HTTPS, and SSH. Coming to the data integrity, as we know that the data should be same at the receiver, the sender end and the receiver end. So in order to achieve the data integrity in the normal traditional systems, standalone systems, we have databases, and these databases are maintained by database constraint and transactions. And these transactions are ruled by ACID properties. We are very much familiar about these ACID properties, where ACID stands for atomicity, consistency, isolation, and durability. So most databases support these ACID transactions and can preserve the data integrity. This is in case of traditional systems. But in the cloud computing environment, data generated by the cloud computing services are kept in the clouds. Keeping data in the cloud means users may lose control of their data and rely on cloud operators to enforce the access control. So access control is another area where one can work for their research work. Well, this data location, of course, this is not our cup of tea. Why? Because as I told that in cloud, the user's data can be stored anywhere in the world. They can the data is scattered across the world, across different regions, and there are so many jurisdictions that happen that are present, and there are so many legal issues we have, and I'm not going to concentrate on this. Why? Because this is not our cup of tea. This has to be taken care by the cloud service providers. Similarly, data availability is one of the prime concerns of the mission and safety critical organizations. When keeping data at remote systems owned by others, data owners may suffer from the system failures or service provider. If the cloud goes out of operation, data will become unavailable as the data depends on a single service provider. So the cloud application needs to ensure that enterprises are provided with service round the clock. So 24 by 7 they need to provide this service. This involves making architectural changes at the application and infrastructure levels. So one solution what we can give here is we can try to implement a multi-tier architecture. We need to adopt a multi-tier architecture which is supported by a load balanced form of application instances running on a variable number of servers. So if one particular server goes down, the other server in the other tier can be revoked, and the purpose of the cloud computing, the purpose of the service can be served. So at the same time, an appropriate action plan for the business continuity and disaster recovery needs to be considered for any unplanned emergencies. If some unplanned emergencies happens, how we are going to continue this business, or how what policies we are implementing to recover from the disaster. All these things we can. Data segregation means, as we know that data in the cloud is typically in a shared environment together with the data from other customers also. So in order to protect your data from the other customer's data, the simple solution is encryption. Encryption cannot be assumed as a single solution for data segregation problems. In some situations, customers may not want to encrypt data because there may be a case when encryption accident can destroy the data. So after encrypting the data, if something happens bad, encryption accident happens, the entire data may be lost. So make sure that encryption is available at all the stages and that these encryption schemes were designed and tested by experienced professionals. This is one very good research area where we can work on it. So you can try different encryption algorithms. You can try various decryption algorithms which provides the best security for data segregation, data transmission, and data security. And these are all the various research gaps challenges we can see. So most of the things we have already addressed, right? So for example, uh, there are also challenges. The research on cloud, many existing issues has not been addressed fully, and the new challenges keep emerging from the industry applications. So, though it has been in the starting stage and many of the research problems has been addressed in the secure cloud computing, still there are so much of gaps we can find in the cloud computing security. So there is a lot of space for the research in the area of cloud computing. These are all the various things we can see here, that data encryption, migration of virtual machines. We can work on this energy management, access controls, reliability and availability of service, multi-tenancy. This will have a quick review here. So if you take the research challenges in the service level agreements, so cloud is administered by service level agreements that allow several instances of one application to be replicated on multiple servers if need arises. So we should have the service level agreements. As a customer, you always have to go through the service level agreements with the cloud service provider. What is the service level agreement? The CSP is providing in case of uptime. So how much uptime it is providing. Similarly, what are the service level agreements that are provided by the CSPs for the backup and archives? Similarly, what is the service level agreement if service gets expired? Will they going? Are they going to keep the data even though the service gets expired? If they are going to keep the data in the servers, how long they are going to do it? So this is a service level agreement research challenge, and this is not again our cup of tea. This is related to the business administrators. Similarly, if you consider this cloud data management, so confidentiality, cryptographic protocols, auditability. So confidentiality can be achieved by making use of these cryptographic protocols. So as a researcher, you can concentrate on most of the cryptographic protocols. You can take a lot of cryptographic protocols and try to apply on the cloud computing environment and try to achieve a best cryptographic algorithm for this cloud computing environment. Similarly, auditability. Auditability can be achieved by remote attestation. So remote attestation, again, it has some problems. As I told, that confidentiality is achieved using the cryptographic protocols, and auditability is achieved by remote attestation techniques. But as we know that the cloud computing is a virtualized environment. In a virtualized environment, virtual machines can dynamically migrate from one location to another. Hence, by using the remote attestation is not a good solution. Why? Because the server keep on moving from one location to another location. So how can you give the remote attestation? That is not a best solution. So hence directly using remote attestation is not a sufficient. So in this case, what you have to do is you need to build trust mechanisms at every architecture layer of the cloud. And there are so many software frameworks such as MapReduce, Hadoop, and there are so many file systems like GFS and HDFS. GFS stands for Google File System. These file systems are different from the traditional distributed file systems in their storage structure, access pattern, and application programming interface. So several research efforts have been studied under this particular area, which is nothing but cloud data management. So you can work on this remote attestation, you can work on these cryptographic protocols, and you can work on these different file systems, how you can adapt it to our cloud computing environment, all these things we can see. Similarly, data encryption. We know that encryption is a key technology for data security. We need to understand data in motion and data at rest encryption. Security can range from simple to very highly secure. That means simple security means which is easy to manage, which costs very low, but frankly speaking, this does not provide a good security. But when you consider the high level security, that means it is very complex in nature, very expensive to manage, and quite limiting in terms of access. The unauthorized users cannot access it. So you need such a, yeah, please. Optimization techniques, sir. And what is the another question, sir? Okay. Okay, sir. Can I address it at the end of the session, sir? Thanks. Right. So coming to this data encryption, we can provide the SSL encryption for accessing the data. Similarly, encryption by self. There is a question arises whether as a customer, we need to encrypt the data, or shall we ask the cloud service provider to encrypt the data? So encrypt it to. Similarly, there is another question that whether we need to encrypt it before storing it or after storing it. All these are the questions we can address here. Um, so here we can, what we can do is we can work on this SSL. Similarly, migration of virtual machines. Nowadays, as I told that the virtual machines keep on moving from one location to another locations, and nowadays most of the cloud service providers like Zen and VMware, they have implemented a concept called as live migration of virtual machines that involves extremely short downtimes ranging from tens of seconds to tens of milliseconds to a second. So even the most predominant technologies like Zen and VMware, they are going to implement this live migration. But there is a problem with this live migration, that is they when there is a memory state that should be transferred consistently and efficiently, integrated consideration of resources for application and physical servers is not considered. So this is where the live migration happens in Zen and VMware. And as a researcher, you can also work on this live migration problems, and how you can address these problems from the live migrations. And similarly, interoperability. As we know that interoperability is making two devices from the different manufacturers to work together in order to exchange some information and use that exchanged information. Right. For this, there are so many standards we need to develop for the interoperability. And as I told that there are so many organizations and so many industry groups, those are working to develop the standards. For example, OGF stands for Open Grid Forum. They are continuously working to develop the standards. So this is also not our cup of tea. Why? Because standards is not developed by the customers or the researchers from the academia. They are developed by the business people. Similarly, access control. As we know that authentication and identity management is more important. So, who is going to access the data? And how we are going to control the access of data? This is done by making use of passwords. So authentication is obviously done by the passwords. So you can work on the password strength, you can work on the frequency of how frequently we need to change the password, and if password and the username is lost, what are the various recovery methodologies you can use, and how we are going to pass the recovery data, and what are all the various locks and ability to audit these access. All these things we can have under these access controls. So one can work on this password strength. That means you can implement your own policies or you can implement your own rules to design a password which is a very strong, which is a very strong password. For example, the latest Google, what they are doing is they are asking us to provide the passwords which are having minimum 8 characters, which should include a uppercase letter, which should include a special character, and which should include numbers also. Like that, you can have your own passwords. You can have your own rules for passwords. You can also work on this one, and how frequently we need to change the password. All these things you can. And the next one is very important thing, where we can do a lot of research here. So energy resource management. Cloud computing, as I told, that it consists of so many data centers, and it has been estimated maintaining a data center is very costlier, and the operational expenditure of the data center is very costlier, and it has been estimated that cost of powering and cooling itself accounts for 53% of the total operational expenditure. So the goal is not only to cut down the expenditure of the data centers, the goal is not only to cut down the energy cost in the data centers, but we also try to meet the government regulations and environment standards. So there is a organization called as GEMC, which stands for Global Energy Management Center, which can help the companies monitor energy consumption patterns from multiple sources. What these patterns will do is they can further be analyzed for usage, cost, and carbon footprint in a number of ways that help in optimizing energy. So, what are the various areas we can concentrate here? Is this is a very beautiful area we can concentrate here. So, you can try to develop a hardware architecture which is energy efficient, or you can try to implement the scheduling, job scheduling, which is energy aware. So you can try to develop some job scheduling algorithms which concentrates or which uh, conserves the energy. Similarly, you can try various networking protocols which are energy efficient. Similarly, you can try to develop the infrastructures which are energy efficient. And server consolidation is another area where you can try to consolidate various servers so that the total energy utilized by the servers can be reduced. So you see here the so many research areas you can find here. So energy efficient hardware architecture, job scheduling, networking protocols, energy aware efficient infrastructures. So, and coming to the next topic, which is nothing but multi-tenancy. The name itself is saying that there are multiple types of cloud application that user can access through the internet, from small internet-based widgets to large enterprise software applications. And when multiple users try to access the cloud computing at the same time, so there may be an issue called as waiting times. So when multiple users try to access the server, the waiting time may increase, and if the server is exhausted, then what is the policy that you are going to implement? So you can try out on this particular area where how you can reduce the waiting time though multiple users are accessing the cloud computing environment. So what is the policy that you are going to use when the HTTP server or any server in the cloud is exhausted? So whether they need to wait until another server is revoked, or is there any other policy? So these are the things you can concentrate on it. So server consolidation. This is another area. I think this particular slide will answer the question asked by the participant. So here you can see that the increased resource utilization and reduction in power and cooling requirements achieved by the server consolidation. So we can make use of this live VM migration technology, which consolidates the VMs residing on multiple underutilized servers onto a single server. So if there are multiple servers in different locations, what they will do is, and if they are underutilized, they are brought simply to a single server, which we call it as server consolidation. So for this, we have two different types of problems we can address here. The problem of optimally consolidating servers in a data center is often formulated by two techniques, which is called as vector bin packing problem and NP hard optimization problem. So here we can implement these optimization problems, or we can make use of these hard optimization problems to provide the security also. So I think this particular thing the participant has got the answer. So you can make use of the optimization for implementing the security challenges in the cloud computing. Similarly, the last one is the reliability and availability of service. So as a cloud service provider, it is very important that the cloud service provider should provide the reliable service, and the service should be available on a round the clock service. So there are so many big giants like Apple's. This is a failure model. So Apple's mobile MC, what happened is they have developed a cloud service which stores and synchronizes data across multiple devices. But at the start, what happened here is many users were not able to access the mail and synchronize the data correctly. So what the users has done is they have moved towards the other areas like Google Gears, Adobe Air, and Curl. So this is so the researcher can also try on different areas where they can provide the reliable service from the CSPs, or they can provide the availability of the service round the clock. All these things they can try it out. So these are the common cloud standards, and as I told that standards are not designed by the researchers from the academia. So there are three types of standards. One is the technical standards, personal standards, and operational standards. All these standards are taken care by different standards organization. For example, we have the IASP, which stands for Institute for Information Security Professionals, and we have another protocol called ISO 27001. All these things, they are going to take care of these standards. So finally, when I just want to give a gist of what are all the various protocols, or what are all the various areas we can work on this cloud computing. For example, if you consider the data transmission security, We can work on the HTTP, we can work on HTTPS, we can work on secure shell. So you can similarly, if you consider the access to servers and applications, you can work on LDAP server, you can work on AD server, that is Active Directory server, or else you can work on the SSO also. Similarly, there is another area where the researcher can work is the SSL and the TLS, secure socket layer and the TLS. Similarly, in the VM security, virtual machine security, we can work on the virtual machine monitors. So in the network security, we can work on various protocols like DNS security, address resolution protocol, round trip time, and coming to we can work on the multi-tier architectures also. And finally, the energy resource, we we can try to implement the energy efficient hardware architecture. We can try to implement the energy aware job scheduling algorithms. We can try to implement the energy efficient networking protocols. We can try to implement the energy efficient infrastructures. We can also try on the live migration. And similarly, for the server consolidation, from the server consolidation part, we can try on these two important things, that is vector bin processing problem and NP hard optimization problem. And from the access control point of view, you can try different password mechanisms, and you can try how you can decrease the wait times and what are all the various procedures to deal with when the server is exhausted. Similarly, we can also try on various cloud standards such as ISO 27001. So I have given a gist like HTTP, HTTPS, SSH, LDAP, AD, SSO, SSL, TLS, VMM, DN security, ARP, RTT, all these things, energy efficient networking protocols, energy efficient infrastructures, password mechanisms, and similarly how to decrease the waiting times and NP hard optimization problems. These are all the various research areas. Extensive research areas are there in the cloud computing area. And finally, the last topic is regarding the big data. Let's begin big data. Here also I told that we'll be going to introduce the big data. We know what a big data is. Big data is a collection of data that is huge in volume, but it still grows exponentially with time. So it is a data with so large size and complexity that none of the traditional data management tools can store it or process it efficiently. And while the big data has been introduced, we have only 4 V's. Now we have around 10 V's, I think. So the V's represent the volume, velocity, variety, value, veracity, like that. And the reason why we are getting this big data predominant in today's environment or today's era is there are so many social networking sites and there are so many e-commerce sites. Similarly, we have weather stations, we have share market, and we have banking sectors, we have healthcare centers, and we have government education. These particular entities are generating the huge amount of data on a daily basis. So this is the reason why we are going into the big data era. Coming to the history of big data, and so we cannot really agree on the true origins of the term big data. Some people say that in the 1990s, John R. Massey, he is the first person to come across this big data terminology, and he is considered as the father of the big data. And some other believe that the term the big data actually was coined by Roger Mogeles in the year 2005. And remember that some people argue that the big data is not taken off until 2010. So, but there are so many proofs saying that the data played a very important role from the ancient Egyptians and the Roman Empire also. So if you consider the ancient Egyptians and Roman emperors, the famous library of Alexandria, which was established in 300 BC, can be considered as the first attempt by the ancient Egyptians to capture all data within the empire. So they have a library which is having around 1 lakh of books. So even the ancient leaders of the world realized that combining different data from various sources could result in an advantage over the other competing empires. Similarly, the ancient Roman military, what they have done is they have utilized various detailed statistical analysis to predict at which border the chance of an enemy getting into our kingdom is more, so that they can keep more and more army over there and they can protect their kingdoms. So the thirst of data is not the today's era. It has been from the ancient Egyptians and Roman emperors from around 300 BC also. But in 2013, the data generation in the 21st century, the generation of data because of these various e-commerce sites and all these things, they have been increased more, and therefore more and more huge amounts of data is being generated. For example, if you take in the year 2013, we have only 4.4 zettabytes of data that is present all over the world. But if you consider that 2020, within just 7 years, the data has been raised to around 44 zettabytes, which is a huge amount of data. And as we know that these particular uh, traditional computing technologies uh, cannot work with this big data. Similarly, these are all the tools which we come across in our daily life, and there are so many industries that are working on these particular tools which are working on the big data. We are very much familiar of Hadoop environment. We are very much familiar with Hive. We are very much familiar with Spark, Kafka, Pig, Drill, Data Lake, Iceberg. All these things we are very much familiar. So these are the various tools and technologies that are available. And coming to the big data issues, we have so many issues like scalable architectures, graph processing, dimensionality reduction, identification of fake news, real-time video analytics, and anomaly detection, handling uncertainties, etc. So I'll quickly go through these particular topics because we are running out of time. So scalable architectures means Hadoop or Spark kind of environment is used for offline or online processing of data. So the industry is looking for scalable architectures to carry out the parallel data processing of big data. So we have huge potential to work on these scalable architectures when we are working on this big data environment. Similarly, handling real data analytics is very important area with the increased accessibility to the internet even in developing countries. There is lot of videos that are generated here, and can the existing systems be enhanced with low latency and more accuracy? This is the question we need to answer. So analyzing the real-time video with the existing architecture is a challenging task. So you need to work on the area such that you can provide some technologies which can process the real-time data efficiently both at the edge and the distributed cloud. Similarly, graph processing. Graph processing, we come across this in the social media analytics. As we know that social media is one of the biggest source of this big data. So, social media analytics is always based on graph processing. So one research area is in the big data is handling the efficient graph processing at a large scale is a very fascinating problem to work on. Similarly, fake news. So we really come across these fake news and these fake news spread like anything, like a virus or in a bursty way. They come from Twitters or they come from WhatsApp. So as a researcher, you need to find out the ways to identify those fake news and to stop those fake news. This is one of the interesting area from the big data. Similarly, dimensionality reduction is another area uh, where the researcher can work on. So one can extend the existing approaches of dimensionality reductions. We know that we already have some dimensionality reduction techniques, but how we are going to adopt those traditional dimensionality reduction techniques to handle the large scale data, or you can propose new approaches to handle the large scale data to handle these dimensionality reductions. So this includes visualization aspects also. So this is a open, you can try out these dimensional reduction techniques and you can put it on the open source contributions to start with and contribute back to the open source. Similarly, there are so many training inference in noisy environments and incomplete data. So one may not get a complete distribution of input data, or the data may be lost due to a noisy environment. So how can you get the meaningful data from the noisy environment? This is the area where you need to concentrate. So we have some techniques like these are all the communication techniques like can the data be augmented in a meaningful way by oversampling? For example, we can make use of a oversampling technique like synthetic minority oversampling technique, or we can make use of GANs, which is a very buzzword in today's machine learning or deep learning environment. So GANs can be used. You can work on GANs. You can work on oversampling techniques to deal with the data that is lost due to noisy environments. Similarly, we have a lot of uncertainty in handling the big data processing. So you can make use of different learning techniques like active learning, distributed learning, deep learning, fuzzy logic theory. See how this particular big data is linked to other techniques also. Other technologies like active learning, distributed learning, deep learning, fuzzy logic. So you, as a researcher, one can work on these different areas like distributed learning, deep learning, fuzzy logic. Those particular topics are not exclusively meant for those purposes only. You can combine those topics to work with this big data also. So this is one of the best research area we can find how to handle the uncertainty in big data processing. Similarly, anomaly detection in a very large scale system is another research area which we can work. Similarly, effective anonymization of sensitive fields in the large scale. So here comes the concept of again privacy preservation. So security plays very important role in the big data also. For example, if you take a healthcare system and if you have a X-ray image of the chest, it is a part of a personal health record, and the personal health records are highly confidential. We cannot share the personal health records of one person to another person. So how we are going to provide the privacy preservation in the area of big data is another research area which we can work on. Right. And the last slide of today's session is these are the different things. Privacy preservation in big data. In the previous slide also we have seen that I have given an example of a personal health record where the data of a particular patient should not be exposed to the others. This is a challenging research problem where the researcher can work on the privacy preservation on the big data. Similarly, auto conservation of algorithms to MapReduce problems. We know that MapReduce is not just the functions. So MapReduce is a well-known programming model in big data. It is not just a function. It is not just a map function and reduce function. They provide the scalability and fault tolerance to the applications. So you can work on these particular MapReduce functions. You can build a library to do the auto conversion of standard algorithms to support MapReduce. The problem here is, though we have the MapReduce functionality, these particular algorithms do not support, the traditional algorithms do not support MapReduce directly. So as a researcher, you can try to build a library which can automatically convert the standard algorithms that supports the MapReduce also. MapReduce functionality. Similarly, automated deployment of Spark clusters. Till now, we have so many clusters, we work on this big data, we have so many clusters, and all these clusters are being deployed by manually, by the person manually. But you can try to develop a code, or you can try to develop a scenario or an infrastructure where you can make the deployment of the Spark clusters done automatically. So a lot of progress is witnessed in the usage of Spark clusters in the recent times, but they are not completely ready for automated deployment. So try to develop a scenario or try to develop an infrastructure that automatically deploys the Spark clusters. Similarly, neural machine translation to local languages. We can use this neural machine translation, in short we call it as NMT. There's a lot of research that is going on in the local university to do the neural machine translation in the local languages with the support with the support and fund given by the governments. So there is a concept called as BET. This is the latest advancement we have in this big data environment in the translation to local languages. BET stands for bidirectional encoder representation from transformers, and you can try to work on this BET. And this is BET is going to change the way of solving these problems. So as a researcher, you can collaborate with some other researcher who is working on this BET and who is working on this neural machine translation to local languages, and you can have a good research area about it. Similarly, interpretability of deep learning models in the real-time applications. So in recent times, we hear the term called as explainable AI. It's a buzzword. So explainable AI means AI which can explain its work. So no longer this machine learning and deep learning are not black boxes. Previously, it was a black box. What is happening inside the AI and ML or DL, we cannot interpret it. But with the invention of explainable AI, we can the AI become explainable. So we can work on some of the techniques like LIME, which stands for Local Interpretable Model Agnostic Explanations, or SHAP, Shapley Additive Explanations. So all these things, algorithms, you can work on it. Similarly, the last one is building a large-scale context-sensitive system is the latest trend. There are some open source efforts, but it requires a lot of effort in collecting the right set of data and building context sensitive systems. So one can choose a research problem in this topic if your background is on knowledge graphs, if your background is on natural language processing. See the importance, or see the uh, link between the big data and the other areas of AI and the other areas of natural language processing, deep learning, fuzzy logic. So big data itself is not a simple research area. It includes the research area from the different other technologies like deep learning, explainable AI, fuzzy logic, all these things. And the last but not the least is building large-scale generative-based conversational systems, which are called as chatbot frameworks. So one specific area nowadays which is gaining momentum is building of conversational systems such as chatbot generative systems. So a lot of chatbot frameworks are available. Making them generative and preparing somebody in real-time conversations is still a challenging problem. So the complexity of the problem increases as the scale increases. So a lot of research is going on in this area. This requires a good understanding of natural language processing and BET. As I told that BET is very important area, which stands for bidirectional encoded representation from transformers. So these are all the various research topics we can come across in these big data issues. So this is all about the research areas. So in the cloud computing, we have so many protocols to work with: HTTP, HTTPS, SSH, um, energy efficient protocols, energy efficient job networking protocols, and similarly SSH, ARP, RTT, and similarly here in the big data, we can come across the different areas like BET. We can work on BET. We can work on SHARP. We can work on fuzzy logic. How we can integrate the fuzzy logic to our big data. All these things we can come across. So this is all about the various research aspects in cloud computing and big data. So this is the end of my today's session. Thank you all. And sir, is it audible, sir? So I think the answer has the answer for the question asked by the participant has been answered, sir. Right? Yeah, please tell us. Please, sir. Okay, sir. So obviously, what we can tell for this question is, when you provide more and more layers for the security, it obviously increases the security, sir. There's no doubt. But for every pro, there will be a con, right? So when you increase the number of layers, you can gain the security, but the operational cost and the maintenance cost to uh, develop such type of multi-layer system will be high. So obviously the answer is very simple, sir. Providing multiple layers will provide high security. There's no doubt about it. But maintenance cost and the uh, implementation cost will be high. So we have to compromise on some of the issues to gain something. So we are gaining the security, but we need to compromise on the cost as well as the maintenance cost. Sir, is it clear, sir? So thank you for watching this presentation. Thank you very much. Yeah, please.
What is the future of blockchain technology?
Madam, actual blockchain technology is a new technology which is not yet authorized in India. You know that India has not yet authorized this blockchain technology, right? Future means, frankly speaking, I attended one particular workshop which is organized in Hyderabad, ma'am, in the blockchain technology only. Frankly speaking, there are no resource person to speak on this blockchain technology. So there is no industry, even industry is not having good resources regarding this blockchain technology. So we have so much of research problems that are available in blockchain, but implementation level it is not possible in India. So we have only one resource person that came from Tech Mahindra, I think. He is the continuous resource person for all the 5 days. We asked the question, what is the reason why you are giving only one particular resource person for all these 5 days? Means they really found it difficult to find a resource person working on this blockchain technology. and they have given the same answer that research orientation in blockchain, we have so many gaps. We can work on consensus protocol, or we can work on encryption techniques, we can work on hashing techniques, all these things. There is so much of research gap, but implementation wise, even the industries are not moving towards it, especially in India. I don't know about the other countries, madam, but this is what is happening. But the future of blockchain in terms of research will be good. Did I answer your question, ma'am? Any other questions, sir? Okay, sir. Thank you very much, sir. Thank you very much, sir.